Today's lesson is again solving logarithmic or exponential functions. So we're going to do some of the same types of problems to review and also a couple of new types of problems. So for both types of problems, we're going to always start off by rewriting our equation with one term on either side. And then we're going to use our inverse function to undo either the log or the exponent. And finally, we're going to solve just using algebra. So let's take a look at number one. So for this one, we first want to start off with one term on either side. So this one already has one term on the left side. This one we want to combine it so that it is one term. So we're going to use our log rule. So this 2 out in front here becomes our exponent. Since these two are being added, if I turn this into one term, so log base a, that a stays here. So now what's happening between my 3 squared and the 5? 3 squared is 9, and it becomes multiplication since it's adding, right? And so this is log a of x. So 9 times 5, we can actually solve that. It is 45. And so now I have one term on either side, so that's my first step. Now I'm going to undo either my log or exponent. So to get rid of this log base a, I'm going to raise everything to the power of the base, which is a. So a to the power of, a to the power of on both sides. These cancel out, and this just leaves me with x equals 45. So that's it for number one. Okay, let's take a look at number two. We've seen this problem before, so again, we first need to rewrite the equation with one term on either side. First thing you should notice is that this is something we can actually get an answer for. This is asking us 3 to what power gives you 9? So clearly 3 squared gives you 9, so this is just 2. So I have log base 3 of x plus 2 equals 3. Now again, I'm trying to get one term on either side, so I need to get rid of this plus 2. So I'm going to subtract 2. This gives me log base 3 of x plus 2 equals 3 minus 2, which is 1. And now again, I'm going to undo my log. So this is log base 3. To undo this log, I'm going to raise everything. 3 to the power of, both sides. These cancel out, leaves me with x plus 2. Over here, what's 3 to the power of 1? It's 3. And now I'm just solving, again, for x. So this leaves me with x is equal to 1. Okay. Let's go on to number 3. So again, this is another review problem that we've done before. So this time, we already have one term on either side. So to undo these exponents, what we're going to have to do is take the log of both sides. So when we take the log of both sides, the point of this is so that we can then move our exponents in front. So using our log rules, we know we can pull the exponents out in front of our log. So this turns into 1 plus x, don't forget the parentheses, log of 0.3, equals 2 minus x, log of 1.7. So my next step, don't forget, it's really important that I am distributing my log to both the 1 and the x. And this log also goes to both 2 and minus x. When I distribute, it goes in front. So 1 times log of 0.3 is just log 0.3 plus x log of 0.3. Over here I have 2 log of 1.7 minus x log of 1.7. So again, be careful you're not actually multiplying the number by this number. The log and the 1.7 stay together. They don't change. Now, just like before, I'm trying to get all my terms with x onto one side, everything else on the other side. So here's an x, here's an x. I need to get these two on the same side. So I'm going to move this whole term plus x log 1.7 onto this side. And I'm also going to move this one, minus log 0.3, over here. So this leaves me with, I have x log 0.3. And if I move this term over here, now it's plus x log 1.7 equals, and so this side I still have 2 log of 1.7, and now I'm subtracting log of 0.3. Okay. So now to solve for x, I'm trying to get x by itself, so I'm going to factor out an x here. So I'm taking an x out of both of those so that I now have an x by itself. And I still have this 2 log of 1.7 minus log of 0.3. Okay, now I'm going to combine so that I only have one log. So to combine these two, since they're being added, this now turns into multiplication. So 0.3 times 1.7. Over here, this 2 becomes an exponent. And now when I combine these two, so I have 1.7 squared minus means that it's going to be division. Right. And to get x by itself now, I'm just going to divide by log of 0.3 times 1.7 on both sides. And so this is what's going to go inside my calculator. These cancel out. This leaves me with x is equal to. So take out your calculator, and I'm going to type in log of 1.7 squared divided by 0.3. Close my log. Divide that, and then log of 0.3 times 1.7. And this is what's going to go inside my calculator. I press enter. It gives me my final answer, which in this case is negative 3.364. And that is it. So just like what we did yesterday. Okay, a couple more problems. So number 4 is one that we haven't seen before because of this absolute value, but it's actually very simple. The steps are the same here. So we're first going to get rid of log base 3 because we already have one term on either side. Get rid of log base 3, we just raise everything to the third power. So these cancel out. So we're left with absolute value of 4x plus 4 equals 3 squared, which is 9. Absolute value just means that we are turning anything positive, right? So what this means, if you're solving for absolute value, means that x plus 4 could either be 9 or x plus 4 could be negative 9. Right, so those are our two possibilities, because if it's 9 or negative 9, they'll both, absolute value of them will both give me 9. So then I'm just solving these two. So minus 4, x could either be 5, that's one answer, or minus 4, x could be negative 13. Okay, so whenever you have absolute value, we're just going to split into two different scenarios. It could either be positive or negative. Okay, last two problems. So number 5, this is one that you haven't seen before, but actually is quite simple, because this right here, e to the 2x, is really e to the x squared. And notice this looks just like a trinomial, right? This looks just like x squared minus 5x plus 4. So the way we solve this is very similar to how we solve trinomials. We're going to be factoring. So really what we're doing here is doing our x box. So a times c is 4, negative 5. We're just looking for what multiplies to give me 4, adds to give me negative 5. So negative 4, negative 1. And so instead of having an x, it's not going to be x minus 4, x minus 1. It's instead going to be e to the x. So this is going to say e to the x minus 4, e to the x minus 1. So just like before, if this is equal to 0, I'm going to set this equal to 0. So both of these set equal to 0, and we're going to solve. So over here, plus 4, I have e to the x equals 4. And to solve for x here, to undo my exponent, I'm going to take the log. But since it's a base of e, I'm going to take ln of both sides. Right? And what happens with my ln and my e here? They cancel out. So x is just equal to ln of 4, which we can type really quickly into our calculator. It is 1.386. So that's one answer. We're going to do the same thing over here. So plus 1, e to the x equals 1. Again, to get rid of the exponent, we're going to take the log. ln of both sides. We get x is equal to ln of 1. And we know already, e to what power gives me 1? E to the 0 power, right? Because anything to the 0 power gives me 1. So in this case, x is equal to 0. Or you could have typed into your calculator and found the same thing. Okay, last problem. So for this one, very similar. This is another factoring problem. But this time, we're looking to see, out of these two terms, what can we take out of both of these terms? We can take out an e to the x. When we take out an e to the x, it leaves us with x squared minus 4 equals 0. Right, so we're just factoring out. X squared minus 4 we could break down even more. Difference of squares, so it's x minus 2, x plus 2 equals 0. And just like for this problem, we're just setting them all equal to 0. So e to the x equals 0, x minus 2 equals 0, x plus 2 equals 0. So e to the x equals 0. E to what power gives me 0? This is actually not possible. Because nothing, e to no power is going to give you 0. So that one doesn't give us an answer. However, we do have answers from these two. We get x is equal to 2, and x is equal to negative 2. So those are our two answers for this problem. And for this section right here, if you wanted to take the ln, let me just show you on the calculator. If you did ln of 0, it would also give you an error because it's not possible.